In a solar system belonging to a star known as the Sun, we find a planet that is like none other in space. It orbits between two fellow terrestrial planets known as Venus and Mars. The planet is the only one in its solar system with liquid water on its surface, an ozone layer, and life. The planet only has one natural satellite, formed billions of years ago when a Mars-mass body collided with the planet. The planet has seen dynasties of living organisms rise and fall, and it is currently the home of a sentient species desperate to know if there are any other planets out there like theirs. The planet goes by the beautiful name Earth. Why is Earth so unique? Why is it the only place in this universe harboring life that we know of? Well, today, we're going to find out. One big factor is, of course, Earth's distance from the Sun. Not too close in, and not too far away, within a range that astronomers call the habitable zone. The habitable zone is a small orbital zone in which a planet would have to be in to maintain surface water. The Sun's habitable zone extends from just inside the Earth's orbit, almost out to Mars. A habitable zone also depends on the star's size. It would be closer in if a star is smaller than the Sun, and farther out if it is larger, since stars of larger size emit more heat and vice versa. Some astronomers believe that we also live in a galactic habitable zone. The Sun orbits the center of our galaxy, the Milky Way, just in the middle between the center and edge, in a small branch of the Perseus arm. In distance, it is about 26,000 light-years from the core. Located in the galactic habitable zone, we are close enough to the center to be infused with heavy elements generated by countless stellar explosions over the eons, but far enough away from the deadly gamma radiation that roars out of the center. Astronomers have calculated that only about 5% of the stars in the Milky Way fall within this galactic habitable zone. Still, there are 400 billion stars in our galaxy. There is one factor that people often overlook. It is right there, but people don't usually pay attention to it. They don't suspect it. It is the moon. Our moon plays an important role in helping Earth support life. There are 4 other moons farther out in our solar system that are larger than our own, but our moon is unusually large in comparison to its parent planet. The reason is because of its origin, which was mentioned earlier. The reason we suspect the moon originated that way is because minerals obtained from moon rocks taken from the Apollo missions are suspiciously similar to those found in Earth's mantle. This is because in that massive impact, Earth was turned molten and its mantle was ejected into space. Fairly quickly, the debris clumped together to form the moon, and Earth slowly turned back to normal. All in all, we are lucky to have a big moon because of this billion-year-old collision. Such a big moon also has a larger gravitational force on its planet than larger moons orbiting much larger planets. If the Earth threatens to tip further on its axis, the moon pulls it upright. This keeps our seasons under control. These tugs also vary the amount of sunlight reaching the ground, and so thus the moon also controls our climate. Life on Earth couldn't have evolved without a stable climate over billions of years. Mars, which has no large moon, suffers wild axial tilts and catastrophic climate changes. So without the moon, we would almost certainly not be here. I believe that the Sun's size also comes into play. It is a medium-sized star with a pretty good lifespan. A planet orbiting a smaller star, such as a red dwarf, would have to orbit closer than the Earth's distance to be in the habitable zone. However, at a closer distance, more extruded force from the red dwarf would likely cause the planet to become tidally locked, meaning that its rotation period and orbital period are the same. Thus, it keeps one face forever towards its master. This same fate has befallen our moon. We only ever see one side of Earth's only natural satellite. So in the case of a tidally locked planet orbiting in the habitable zone of a red dwarf, is there any hope for life? There is a solution to this tidally locked problem. Earth's gravity holds onto a strong atmosphere. Due to the day-night cycle, our atmosphere has developed circulation patterns to spread heat from the sun evenly around the globe. Without this, it'd be even colder at night for us. A tidally locked planet orbiting a red dwarf could in fact develop this heat circulation in its atmosphere, and we are getting closer to finding such planets. Take for example the Gliese 581 system, 20 light-years away. Gliese 581 is a red dwarf located in the constellation Libra. Because it is so dim, you cannot see it with your naked eye. It has 7 planets orbiting it, Gliese 581a, b, c, d, e, and g. C and D are within the habitable zone. However, planet C, being closer in than planet D, has likely, if not, will eventually turn into something similar to Venus. What I mean by that is that the water cycle on Planet C will speed up due to intense heat. Water vapor is a greenhouse gas, meaning that it cannot be removed from the planet's atmosphere. The water cycle will continue, evaporating more water, building up more water vapor, and trapping more heat from the red dwarf. This runaway greenhouse effect will lead to Planet C's oceans boiling away entirely, turning it into a planetary equivalent of hell. A hothouse, just like Venus. Planet D, meanwhile, lies on the outside margins of Gliese 581's habitable zone, meaning that it could very well contain sustainable surface water, and maybe, just maybe, life. The Gliese 581 system isn't the only place in the Milky Way we suspected harbors life. Dozens of planets have been found orbiting stars within their habitable zone, not just red dwarfs, but also sun-like stars. Someday, we may be able to develop the technology to see, or maybe even go there, for sure.